Magic lenses are filters that modify the presentation of application objects to reveal hidden information, to enhance data of interest, or to suppress distracting information. We present a tool capable of interactively rendering 3D volumetric magic lenses for augmented reality. This interaction tool can apply different rendering styles to portions of a scene depending on contextual information. Context-sensitive magic lenses can be used to satisfy visibility constraints in dynamic illustrations with techniques such as non-occludable, ghosting, cutaway, or occluding. Although required to be convex, objects inside these lenses can be of any arbitrary shape. This means that bounding boxes can be used as the lens of more complex objects. Our interaction tool can be also used to enhance the information of objects depending on their context. In this example, a sphere is used to give more detailed information to underground street pipes depending on their type. Moreover, buildings in the field of view of the user are cut out to show the information behind them. In this example, a lens is used to visualize the inner portal and hepatica vessel trees of a liver. Unlike previous attempts, we use contextual information to apply different rendering styles when intersected by the lens. Observe how the portal tree is rendered in red, while the hepatica is rendered blue when intersected by the lens. Our X-ray tool can also be attached to portions of the viewing frustum of the user. Objects intersecting these portions can be applied different rendering techniques. Notice how the parts of the house that come across the lens are semi-transparent, while furniture is given a blue colour and characters are rendered as red. In AR environments, sometimes objects can present some visual ambiguity. In this video, the same vessel trees from the previous example are initially indistinguishable from each other, although contextual information shows that they are different. Traditional tools would have to apply a rendering style change to the whole of the scene. Our interaction tool provides a localized visual disambiguation with the aid of magic lenses. This is only possible with a context-rich scene graph. Observe, once again, how the vessel trees are rendered differently when they are intersected by the lens. The use of context sensitivity allows the complexity of a scene to be shifted to the scene graph's data structure. Objects in this example are not grouped hierarchically, but by context. This means that these objects can be scattered around our graph and still be affected appropriately. On the video, the lens that is intersecting the objects affects their rendering style depending on what context family they belong to. By using multiple context-sensitive 3D magic lenses, we are able to apply different rendering styles to a single object, depending on which lens it intersects. AR scenes can exploit the use of our tool, given its ability to create arbitrary 3D lens combinations interactively. In this video, you can see a scene consisting of a human liver's portal and hepatic vessel tree, as well as a couple of tumours. Here, for example, the user wants to find the location and the geometric relationship of the tumours and the two vessel trees. For this, we first search for the tumours intersecting the entire scene with a lens that only renders these and that at the same time, turns the intersecting vessel trees transparent. To find out about the relationship of the tumours and its surrounding vessels, we now add two more lenses that each renders one of these trees. Notice again that the trees and the tumours are coloured differently. By interactively visualizing and removing parts of the vessel trees, while seeing the tumours in an appropriate colour, we are able to create a mental map of the relationship with the vessel trees. This aids us in better understanding the 3D scene.